In the case of SR1, it will use a nuclear fission reactor for both power and propulsion. Just to set our baseline here, nuclear fission refers to splitting the atom to release energy. It's the kind of reactor that has been used in every nuclear power plant on Earth since the 1950s. Now, in terms of using that to power an engine in space, there are two kinds of nuclear propulsion that we have to choose from. The first is nuclear thermal. This is the most similar to our traditional rocket engine because we are essentially just pumping liquid fuel through our nuclear reactor. We use hydrogen as that fuel source because it's the lightest element in the universe, so it doesn't weigh down our spaceship, and then we chill it down to a cryogenic temperature to create a liquid fuel. Now here's what makes this work. All of the atom splitting releases an incredible amount of energy, which is going to take the form of heat. When super cold liquefied hydrogen hits the super hot nuclear reactor, it will rapidly expand into a gas. That gas will then escape out of the engine through a nozzle, and the flow of gas through the nozzle will create thrust. Again, very similar to our typical rocket engine, only a conventional rocket relies on combustion to convert liquid fuel into exhaust gas. And since combustion requires oxygen, and there's none of that in space, it means the vehicle has to bring along its own oxygen supply. And this adds a lot of extra weight, which prevents us from carrying more cargo. All in, a nuclear thermal rocket engine is going to end up being about 5 times more efficient than a conventional rocket, which basically means that you only need to carry 1/5 the amount of fuel. So now we can either travel 5 times faster, go 5 times further, bring 5 times more cargo, or choose any combination of those 3 things.